Alright, so what if there is repetition allowed? That's what the next one is. When order matters, we want distinct objects, but repetitions allowed. So I want you to go ahead and read this page first, and after you've read it, I'll kind of break it down for you. So take a minute now, go ahead and pause the video, and read this page for me. Alright, so why do we care about this? What's this all about? Here's really what it comes down to. Let's think about my name. My name is Nathan. What if I wanted to, that's 1, 2, 3, 4, 5, 6, that's 6 different ways. So what if I wanted to rearrange the letters in my name? And I care about the order of it. Well, let's think about it. What would happen if I swapped my two N's? Would it be a distinct spelling? Well, no, it wouldn't, because there's repetition of the N's. For instance, if I swap the first N in the A, then it would be A-N-T-H-A-N. That's a complete distinct way of arranging the letters of my name. But when I swap two that are the same, it's not distinct from the other. So how do I remove that repetition? And that's where this next formula comes in. Here's what the formula essentially says. Take the total on top, always do the total factorial on top, and that's if you were, like, for instance, I have 6 letters, so that would be 6 factorial in my name. And then what I want to do is each of the letters, I want to put the number of times it occurs with a factorial there. I do want you to remember that 1 factorial is equal to 1, so 1 factorial I would never put into my calculator. So let's think about it. Let's think about how many N's do I have, how many A's do I have, how many T's do I have, and then how many H's do I have. It seems there's 2 N's in Nathan, so that'd be a 2 factorial. There's 2 A's in Nathan, so that's a 2 factorial. There's 1 T, so that'd be a 1 factorial, and 1 H, so that'd be a 1 factorial. And now I need to put this into my calculator. Again, I want you to be extremely careful putting this into your calculator. Anytime you have multiple things in the denominator, please use that fraction button. It looks like this on the calculator. Use that fraction button to do it properly. Otherwise, you have to put the denominator in parentheses or you will not get it right. So what am I putting in my calculator? I'm putting 6 factorial over 2 factorial times 2 factorial. I don't need to put the 1 factorials because I know those are just 1s. When I do that, let's see what I get. When I put this in my calculator, I'm getting 180 total distinct ways of rearranging the letters in my name, Nathan. So, let's go and let's look at this next one right here. It says a password requires 17 characters. If a person who lives on 155 Nunn Road wants a password to be an arrangement of characters 155 Nunn, being N-U-N-N, how many different passwords are possible? So I want to order, let's count how many objects we have here. Let's see, there's 1, 2, 3, 4, 5, 6, 7 total objects. So the total is 7. And I want to arrange them. Usually it would just be, if it's all 7 that I want to arrange, it would be 7p7 or 7 factorial. But the issue here is I have some repetition. So what do I need to consider? I need to consider how many 1s there are, how many 5s there are, how many n's there are, and how many u's there are. So let's take a look. It looks like there's 1 1, so that's 1 factorial. There's 2 5s, so that's 2 factorial. There's 3 n's, so that would be a 3 factorial. And then there's 1 u, so that would be a 1 factorial. Again, to simplify this, knowing that 1 factorial is 1, I'm going to change this to 7 factorial over 2 factorial times 3 factorial. I'm going to use that fraction button in my calculator, make sure that what I put in my calculator is exactly what I get or what I see on my paper. Go ahead and do that now. I seem to be getting 420 distinct ways, distinct passwords using 155 Nunn. Those would be distinct passwords.